Here is the part 2 of the video. Here we will discuss estimating the risk using cross validation. Here, cross validation is a widely used technique in machine learning for estimating the generalization performance of a model and selecting its hyperparameters. So, what is cross validation? Cross validation is a technique used in machine learning to access the performance of a model on unseen data. It helps to prevent overfitting and gives a more reliable estimate of how well the model will generate to new data. That's how it was. How does it work? Splitting the data. The data is divided into five folds. Here, five folds. Okay, fold one, fold two, fold three, fold four, fold five. Okay, iteration. Iteration one, iteration two, iteration three, iteration four, iteration five. Okay, these are all four. These are all fives. Where T is training, where T is testing and Tn is training data. Okay. Here we assume that in iteration one, fold one is used as a test set and the remaining of folds 2, 3, 4, 5 are used as training. Okay. This one is training. Iteration 2, fold 2 is used as a test and the remaining test 1, 2, 4, 5 are used as training. The model performance on fold 3 is evaluated. Like that, iteration 3, iteration 4, iteration 5. Finally, the average performance across it across all iterations is calculated in the given overall estimate of the model performance. So, it is common types of cross validation. K-fold cross validation. The most common type where the data is divided into K equal sized folds. Leave one out cross validation. Each sample is used as a test set once in least one out cross validation. Next example of cross validation is stratified K-fold cross validation. It ensures that each fold has a same proportion of class labels as a original dataset. Okay. One common application of cross validation is to estimate the risk of a model. Is is to estimate the risk of the model, which is expected loss on unseen data. Okay. So first one is data splitting. What is data splitting? Data splitting is a technique used in machine learning and data analysis to divide a dataset into two or more subsets, typically for training and testing purposes. How many types? There are two types. First, training set and testing set. The data is split into two parts. One is training set and one is testing set. Okay. Next, we will go into here. The data is further split into K subsets. In K-fold cross-validation, the data is further split into K subsets. Okay. Training and validation. The model is trained on K-1 folds and validated on the remaining fold. This process is repeated K times, with each fold serving as a validation set once. The model is trained on K-1 folds and validating on the remaining fold. What is K-1 folds? K-fold cross-validation. The model is trained on K-1 folds and tested on the remaining one fold. Here's a breakdown. K means Here K means the total number of folds. K minus 1 means the number of folds used for training. 1 means the number of folds used for testing. For example, if K equals to 5, then K minus 1, 5 minus 1 equals to 4. This process is repeated K times, with each fold serving as a test set once. Okay? Error calculation. What is mean by error calculation? For each of the K iteration, the error, it is also called as a risk, is calculated based on the model's performance on the validation fold. is calculated based on the model performance. The error is calculated based on the model performance. On which part? Validation fold. Okay. Next one is average loss. After all k iterations, the errors from each fold are averaged to produce a overall estimate of the model stress. The average error gives a more reliable indication of how the model is expected to perform on unseen data. So, here is an example. Suppose you have a data set of 100 samples and you decide to use k-fold cross-validation. Okay, split the data into 5 folds and 20 samples each. Next one is train the model on 4 folds, 80 samples. Next, we discuss about briefly and validate it on the remaining 1 fold, 20 samples. Repeat this process 5 times, each time using a different fold for validation. Calculate the error for each of the 5 runs. Example, accuracy, mean squared error. Finally, average these 5 error values to estimate the model risk. Here, visualization 5-fold cross validation. Okay. Here we have 100 samples in our data set. We divide them into 5 equal folds. Okay. One, 2, 3, 4, 5. Okay. Next, step 2. Training and validation process. 5 iteration. For each iteration, 1 fold is used for validation and the remaining 4 folds are used for training. Okay. Fold 1 as validation. First iteration. Train on fold 2, fold 3, fold 5. Validate on fold 1. Train 11 to 50. Validate. Which one is validated? 1, 2, 3, 4, 5. This one is valid. Next on fold 2. Here 1, 3, 4, 5. Using this diagram, you will clearly understand what was going on. 4, fold 2, fold 3, fold 4, fold 5. Validate on fold 1. Train 11 roll 13 to 50. Sorry. Fold 2 as validation. Here train 1 to 10, 21 to 50. Here fold 1, fold 3, fold 4, fold 5. Validate on fold 2. Validate on fold 2. Next iteration is validate on fold 3. It train on fold 1, fold 2, fold 4, fold 5. In 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 fold 4, fold 1, fold 2, fold 3, fold 5. In fold 5, fold 1, fold 2, fold 3, fold 4. Okay? I Next, step 3, error calculation. Example error values for each fold. Fold used for validation MSC error. Here, for each iteration, we will train the error. We will train the model and evaluate the error. Example, mean squared error, mean squared error. Okay. Fold for using validation. Fold used for validation. That one is fold 1, fold 2, fold 3, fold 4, fold 5. In fold 1, we got error 0.0101. In fold 2, 0.0095. Fold 3, fold 4, fold 5. Now, averaging the errors. The average error gives an estimation of the model generalization performance. Average error. What is MSC? MSC means mean squared error. Okay. Final error score is more reliable estimate to how well performed on new unseen data. Here we will average by 5. Sum of all values by total values. Okay. Here is the answer. In exam purpose, this one is okay. This one is exam purpose లో మనం ఏం చేయాలంటే ఇక్కడి నుంచి ఇక్కడి వరకు రాస్తే సరిపోతదనమాట. ఇదం ఇదంతా మీకు ఈ పైవన్నీ మీకు జస్ట్ అర్థం అవ్వడానికి మాత్రమే ఇవి చెప్పాను. ఎగ్జామ్ పర్పస్‌కి ఎస్టిమేటింగ్ నుంచి ఇక్కడి వరకు రాస్తే సరిపోద్దనమాట. ఎగ్జామ్ పర్పస్‌కి. ఎస్టిమేటింగ్ నుంచి ఇక్కడి వరకు రాస్తే అన్‌సీన్ డేటా వరకు రాస్తే సరిపోతదనమాట. ఓకే. మీకు ఈ వీడియో గాని నచ్చితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేసుకోవడం మాత్రం మర్చిపోకండి. నాకు చాలా టైం పడింది ఈ వీడియో చేయడానికి. మొత్తం అన్ని రీసెర్చ్ చేసిన తర్వాత ఈ వీడియో చేశాను. సరే థాంక్స్ యూ.